Back to my YouTube channel. We're still under fluid mechanics, is ventilation. This is N6, right? So please subscribe to my YouTube channel and click that notification button so that you'll be notified whenever I post a new video. Right, you can feel free to like and comment and share this to your fellow classmate. Okay, let's attack this example 3. It says read as follow: a fan delivers, this is the one that delivers 20 cubic meters per second of air into a duct that splits. You see, it splits into 3 branches at one point. So something like this goes, then it splits here, it splits into 3 branches. You'll have first one, also here we have the second one, then here we'll have what, the third one. According to the law of the quantity of flow, right? Remember the Q that is entering, let me say Q in, let me just say Q in, enter, or you can say Q enter, the one they say is 20, they deliver 20 cubic meters per second, 20 cubic meter of air into a duct. It's entering here, and as it flows, it is splits here, would split, other will goes there, other air will goes there, other air will goes there. But what we know, as the discharges here, this air, the sum of this air must be equal to the sum of what entered, the sum of air entered. That means the sum of air, let's say branch 1, let's say branch 1 plus branch 2 here, Q2, plus branch there, Q3. We must use this law, we must apply this law. Hopefully you understood this. So okay, it's fine. It says split this into 3 branches at a point. The dimension of branches are, we have given A, so I can say here, simply say A. They say you have branch, says this, it has, is 30 meter long, 700 millimeter wide, and 800 millimeter high. This is clearly this. Imagine this. If you can read that, I think that you see that it is a rectangle. It can tells you it's a rectangle. What this rectangle is like this. You know, this is a rectangle. That one is not a square. Hopefully you understand what is going on there. They've given us the length there of this rectangle, then they've given us the depth, also the width, how wide it is. As you can check here, wide is 700 millimeter, which is divided by 1000, simply 0.7 meter. Then they says again it's 800 high, that means is 0.8 meter. So the length here is the one that you have given, which is 30. Yeah, remember our perimeter, we focus on this front, on this cross-sectional area when we are calculating the surface rubbing. Remember the surface rubbing is equal to perimeter multiplied by the length. So yeah, we'll need to calculate the perimeter, also the length, so we'll use this. So as you can see that, so I can say we know we have A there. We can calculate, let me just say for A, let me just duct A, I can say just duct A, or branch A, or let me just say branch A. Then I can calculate the area. Area is pi over 4 d squared, then pi over 4 multiplied by the, oh sorry, cannot be like that, it's not a circle. Oh, I'm used to see it's not a circle cross sectioning, wrong. I said I've just write it now, that is a rectangle. What I'm doing, the area, I can say duct A, or let me just say branch 1 to make it easy, because I used the example with the I can say branch 1. Okay, area 1, the area 1, right, simply equals to, you know, this it is what? It's height multiplied by width of the rectangle. That means, you know, the area is height multiplied by width, whereby is high by what? Sorry about that noise there of the alarm. We know that it will be 0,8 multiplied by the wideness, which is the width, which is 0,7. This will give us 0,56 cubic meter, sorry, meter squared. What is wrong with me actually now? Then surface rubbing for object A, and I said is perimeter multiplied by the length, the perimeter of the rectangle. Remember, the perimeter of the rectangle, you sum up all the four sides. You see we have 1, 2, 3, 4. You have 4 sides. Sum up all the 4 sides. Remember, here you simply have 0,7, right? Yeah, what is that? 0,7. Here we have 0,8. That means also this side will be 0,8. There will be 0,7. You add this, you sum up that. So this will simply 8 plus 80. So that means the perimeter of the rectangle, the formula for perimeter is simply 2 width plus height. Use that. 2 width plus height multiplied by the length. Then you know it will be 2 width is 0,7 plus, here this is plus, isn't it, here, plus height, which is 0,8 multiplied by the length. The length is that one we've given, is like this. That is the length, which is the length that we've been given there. They said it is 30. Then if you multiply this, supposed to get that S1 surface rubbing for this one. If you multiply there, simply just get, if you punch this on your calculator, will be 90. Remember, it will be 90. This is measured in cubic meter. This is what we have. It's fine, we have this. We are done with this. Let us check for let me say branch, or let me say duct 2. Then we'll have area 2, which is area, we know the height of that one. Come here, is what is 0, is 950, which is the, when you divide this by 1000, you'll get 0,95. This unit divided by 1000 will be 0,65. So there we have 0,95 multiplied by 0,65. This will be 0,617. It's fine. Multiply by 5. Since it's not the final answer, let me just leave it to for decimal place, since it's not the final answer yet, right? So then we have, again, you come surface rubbing for 2 is perimeter multiplied by the length. You know the perimeter of the rectangle is 2 height multiplied plus width multiplied by this length. Then here will 2, this will be equals to 2. The height there, here is the height, we have the height there, 0,95 95 0.95 plus the width, which is 0.65, right, multiplied by the length, which was 15. Here it's 15 there. So if you punch this, you'll get that S2 is simply equals to 48 cubic meter, or meter squared, not cubic meter. Then remember we have 3 branches, then I can say branch 3, or let me just say duct 3. Yeah, let me just say duct 3. Then I'll just say area 3. Height multiplied by width. What is the height? Height there is, you see, they say 1000. It's 1100. You divide this by, should divide this by, you see, 1100, divide that by 1000, you'll get 1,1. This will be just 1,1 meter. Then we divide this, will be 0,85. Okay, 1,1 multiplied by 0, 1 by 1 multiplied by 0,85. Right, that is an area. Then when you punch this, your area will be 0,935 squared, like that. Then what about the rubbing surface, which is perimeter multiplied by the length? But our perimeter of the rectangle is 2 height plus width multiplied by the length. Then this will be 2 1.1 plus 0,85 times the length. The length is 60 long, which is 60. If you punch this, supposed to get that. This will be 2,4. This will be 243 cubic meter. Oh, I have punched wrong on my calculator. This is simply just 234 meter squared. Then we are done with this surface rubbing in the area. So of all these 3 branches, so we know that PR, our formula, right, K S V squared over A. We know this. Let me just make V the subject. If you make V the subject, you'll multiply there. Then will be PR multiplied by A. Then divide by KS. Then you divide that by KS. Remember, you have the square to left with square to take the square root both sides. This and this will cancel a V. PR multiplied by AKS. This will be K multiplied by S. So but they said, we know that they've told us that, let's check our information. They say equal value of k. They said equal value of k, equal value of k. That means here equal values of k. That means we won't consider this is not the equal values of k. And then they said equal values of k. I will cancel this because they said is equal. Also they've said same pressure. So if they say same pressure, that means pressure 1 is equal to pressure 2 is equal to pressure 3. That means the first duct pressure and the second duct pressure and the third duct pressure is the same. That means PR will goes out. That means we'll be left with A over S like this. This is your formula. What is this? What is not the same? It's area and the surface rubbing. So this is what you're supposed to. Then let me just say 1 like this. That is what we'll have. Then this is a velocity. Let me say V1. No problem. That is the velocity. I can say V1. Then they say we should calculate Q. They want Q1 and Q at 2, Q at range 3. Want these Q's. So we know that Q actually is given. Q is given is equal to area multiplied by velocity. Okay, I can say Q1. Here I can say Q1 is equal to area 1 multiplied by velocity 1. So will be area 1 multiply the velocity is this, which will be square root of area 1 over S. Right, this is what we'll have there. Then we do the gymnastics. The area 1 you've calculated, we found that is 0.6 here. Area 1 0.56 here. It's an area 1. We have found it. And then surface rubbing, it was 90. Yeah, that was area 1 over the square root. Area 1 is still the same, 0.56. Surface rubbing, which is 90, the one I've just said. Then we punch this, supposed to get that. The rate of flow here, Q1 is equal to 0.044. Right, that is 0.44. But you know this is what the rate of flow. This is what the rate of flow. Then we found Q1. What about Q2? This pattern, just continue with that Q2 now. That is it. Another thing now we're supposed to find Q2. We want Q2, right? So same formula that will apply. I've manipulated this formula, right? Remember here. This formula. So I can simply change the value. I can say 2 now. Remember that one was 1. Now I can say, okay, I can say V2, then multiply by area 2. Okay, let me just say V2 will be square root of area 2 over S2. I can manipulate like this. Then Q2 is equal to area 2 multiplied by the velocity, whereby this is the velocity of 2, which is area 2 over S2. So Q2 area 2, we have calculated area 2 here. Here it is. 0.6175 multiplied by the square root 0.6175 over the surface rubbing, which is 48. We have calculated it here, which it was 48. So when we punch this on our calculator, find that Q2 will be equal to 0.07 cubic meters per second. Same thing, then Q3 say will be area 3 multiplied by the square root area 3 over S3. I think you have seen now the steps how it takes. So now we know area 3 is 0.935 here. Then surface rubbing 234, right? 0.935. Then here we'll have 234. Q3 simply 0, in actual fact those are ratios. With the ratios would be 0.059. Actually this is ratios, supposed not to have. These are ratios, will be Q ratios. This will be, we won't have SI units there first. But no, let me just leave it like this. Just leave it like that. That is what we have there. This is what we have. So you can simplify the ratios. You can simplify the ratios. You can find the ratios. You can find the ratios. Okay, this is what we have, no problem. Okay, this is in it's in cubic meters per seconds. So we have done. Now let us say we know I want us to find the ratios of these, because there are 3 of Q3. So if you find the ratios, I want the actual Q1, Q2, Q3 will simply equals to Q1. Here is Q1. Multiply this by 1000, multiply this value by 1000. Want it to be if I multiply that by 1000, I want it to be ratios 0.044 multiplied by 1000 will be 44. I would have 44. Then Q2, here is Q2, I multiply this by 1000 also. That will be 70. Then Q3, I multiply this by 1000 also. This would be 59. So these are the ratios of rate of flow. We found the ratios of rate of flow. And now if I can take the ratio, I can say Q2 over Q1. For argument's sake, that will simply give us 70 over 44, right? If we take these are the ratios. Then Q2 over Q1, if I punch this, simply equals to 1591. Then I make Q2 the subject, or multiply by Q1, there would be 1591 multiplied by Q1. So we have this equation 1 there. Then we have that equation 1. Then I can say Q2, right? Q3 we have done with Q. You can say Q2. We've used Q1 and Q2 and Q1. I can say now Q3. Let me take with N. I can say inside Q1. This is simply equals to, we take the ratios. Q3 is 59 over Q1, which is 44. Right, it's like that. 70 is for Q1 is 44. Taking the ratios then. After taking the ratios, if you punch this on your calculator, Q3 over Q1 will be equals to 1341. Then I multiply by Q1 there, by Q1 there, we'll have 1,341 Q1. Why? Is because here I have Q1. As you can see, also that I've decided to make Q1. You see, this is equation 2. That is what we have, right? But we know now Q entering, we know that will be same, will be equal to Q1 plus Q2 plus Q3. I've told you, remember this is 3 branches. We have 3 branches. Q entering will same as Q1, Q2, Q3. This is what we have there. You understand this, right? Fully understand this. So this is simply what Q entering we've given that way. It was 20. Yeah, here if I still remember the flow, the one that flowing into duct, this is entering into is 20. We have 20, which is equals to Q1. Do we have Q1? No, I don't know the value of Q1. Here I don't know the value of Q1. We don't have Q1. I'll just say Q plus Q2. Let me check. Here is Q2. We know that Q2 is equal to this, equal to 1,591 Q, 1,591 Q1. That is what we know. 1,591 or 9 is 91, right? Plus now, what is Q? What is Q3? This you have substituted. What about this now? Q3. Here is Q3, which is 1,341 Q1. So ladies and gents, we have Q we have Q. So these are like terms you can add there. This simply as 1, same as 1 plus 1,159 plus 1,341. You just add there 1 comma that 1 plus 1,591 plus 1,341. This is 3,9 3,9 what 3,932, but we have Q1, do not forget. Then we divide by this 3,932, 3,932. Then we divide there, that will cancel. Here we'll have Q1 is equal to 20 over 3,932. When you punch this, what is the value there? Q1 will simply equals to what? If we punch there 20 over 3,932, 5,07 or 5,086, 5,086. So this in cubic meters per seconds, right? So we have Q1, Q3. You see all this there in terms of Q1, so can find Q1 now is so easy. You can simply substitute Q2. We know we did this. Now here it's simple now. You know how nice is this now? This will just become nicely. So Q2 here, no, Q2 is equal to this. Now we can just say Q2 is 1,591. Substitute that Q1 that we got here, multiply by 5,086. This is 5, right? So 1,591 multiplied by 5,086. This will be 8,092. Q2 will be 8,092 meters per second. Oh, cubic meters per second, right? This is in cubic. So Q3, this is nice. Now Q3, Q1, we know Q1 is 5,086 multiply that 1,341 times 5,086. This will be 6,82. Yeah, 6,82, right? 6, sorry about that. This will be 6,82 cubic meters per second. Yeah, so thank you guys for your time. Thank you for watching. So we have all of these Q3, Q2 and Q1. So thank you guys for watching. Please do not forget to subscribe to my YouTube channel and click the notification button so that you'll be notified whenever I post some new videos. Share this to your fellow classmates. Thank you.